Hello everyone. So in this lecture we are going to talk about multi-level circuits using NAND gates. So in the previous class we have discussed about how to convert a circuit containing AND OR to a NAND gate, a circuit containing only NAND gates. However, there is one limitation here, is that if we follow this procedure, then to follow the algorithm that we discussed, the Boolean function must be in the sum of products form, SOP form. Okay, but sometimes a function may not be in the SOP form, it may not be in any standard form. So we may have a function like this, say AF is equal to A into CD plus B plus BC dash. So for this, it is not in the sum of product forms. Of course, we can expand it and then we can write it in the sum of products form. But what to do if we have a function like this? We can write it in this format and then follow the same algorithm. But we may have a multi-level circuit out here. So let us look at the multi-level circuit using this. So I may have something like this. So I have CD, C and D. I am using an AND gate. Okay, then so our original function was CD plus B. So CD plus B. So CD and B will go to a OR gate here. So I get CD or B. Then this is AND with A. So AND with A. Then for the next term, for this term B C dash. So I use B here and C dash out here. So B and C dash. So B and C dash, we use the AND gate out here, and then finally we do a OR of all of this. So finally I get a F. So this is a multi-level and or gate circuit. So how do we convert this into a circuit containing only NAND gates? So what we can do? Let us look at this. So for multi-level, the general procedure for converting a multi-level AND OR diagram into a all NAND diagram can be like this. Again, step 1 is what you do: convert all AND gates to NAND gates. And what format? Which format we'll use? We'll use the AND and invert. And invert format we'll use. Okay. Then step number 2, we will convert all the OR gates into NAND gates. Okay. But here now the NAND gate, the symbol that we'll use will be our invert OR. Okay. So all AND gates we will convert it to NAND gates using AND OR, and all OR gates will convert it to NAND gates with invert OR symbol. And finally, so we will check all the bubbles in the diagram. So let us look at the example that we had, this particular example. So we will convert for all the AND gates, we will convert them into this symbol. So I have one more AND gate out here, so this will also become this. All the OR gates will become invert OR format. So here also I have an AND gate, so I'm going to convert it into NAND gate, and this would be a invert OR. Okay, now what is the third step? The step number 3 is that we will check all the bubbles in the diagram. So for every bubble that is not compensated by another small circle along the same line, insert an inverter. So in the same line, if we do not have, we look at all the bubbles, and then if it is not compensated by a bubble, then we will put a bubble out there. We'll put a inverter along this line. So I had here, I had CD. So output of CD is going here, and then I had B here. So B does not have any. B is going as here. B is not going directly. It is going as a bubble. So it is going here as an inverter. So what we will do? We will take B dash. So in the previous, here we had B out here, but here it is going in as with a bubble out here. So here we will put B dash. So B dash, and this complements it, it becomes B. Similarly, I had output of this was going to this, and then I had A. I don't need to do anything. I'll keep it as it is because it is not going in as a negative or a inverted. So we keep it as it is. Then next, last two was B, C dash. So B and C dash. Again, this is not going in as a bubble. So this is also already negated. So we get this. So what we have now is we have implementation of the multi-level NAND gate logical circuit. So these are the steps. So for the step number 3, you can write that negate literals that is not compensated by another small circle in the same line. Okay, so this is quite straightforward. Every AND gate we've converted into a NAND gate of the same format, of the AND invert format, and every OR gate we converted it into a NAND gate using the which uses the invert OR symbol. And here for all of these three, the AND gates, we converted it into NAND gates using your AND invert. And here, because B was here, it entered as it had a small circle out here for negation, so we had negated this. For B, C dash or the other variables, they came in as it is, as it was in the original, so we keep it in the same format. So this is your multi-level NAND representation.